Yeah, yesterday we discussed about the photoelectric effect. So what do you mean by photoelectric effect? When I such a intensity or frequency of light which is going to be incidenting upon a metals, that metal should be different types of metals, either alkali metals, like that, which may constitute the photocurrent due to the photoelectrons. So this process, you can call it as a photoelectric effect. So what is Einstein's photoelectric equation? Let us discuss about that. According to the Planck's idea, the light consists of photons. Okay, E equals to h. The energy of the photon, which is nothing but E equals to h. So later on, Einstein, he has been proposed that the explanation of the photoelectric effect. So according to that photoelectric effect, one photon is completely absorbed by one electron. Okay, so that one photon, that means where the photon is comes out light energy. So that I just want to show you here. So the symbolic representation of the photon, this one. What is the energy of the photon? H nu. So this must be equals to E. So that where H is the Planck's constant, mu is the frequency of the photon here. So that which the photon which is going to be light energy. So this is the light energy. According to the Max Planck, he is proposed that here the energy of the light which is travels like a discrete components, not in a continuous. So that energy you can call it as a quanta. Okay. So that is in the form of waves. Wave packet energy is equals to h nu. Each and every wave packet you can call it as a quanta here. So that's why on his name Max Planck. So they have been called it as a here quanta. So which is going to be incidenting on a metal plate. So that what will happen here? Yesterday I already show you the diagram for the photoelectric effect. So that this is going to be emitting the energies. That means electrons. This metal plate, see the cathode, and here anode is there in an evacuated glass tube. So that here if you increase the intensity is also increases, the emitted photons is also going to be increased. Or else if you want to change the frequency, that is also, that means frequency means lambda. Wavelength is also going to be changing, and also the photocurrent value is also going to be changes here. Okay, so that is the case. So what about the Einstein said one photon which is completely absorbed by one electron. One photon here where the electrons on the metal plate. So that which can gauge the quantum of energy which may be emitted from the metal plate. Next. So the photons energy which may be used in two parts. One is that to free the electron from the atom, away from the metal surface, and this energy which is known as photoelectric work function of the metal, and this is denoted by W0. So that you can discuss this with the equation part, and other part which is used to giving the kinetic energy. So that how the kinetic energy by changing the potential potential difference by applying the potential difference between the cathode to the anode plate, so that the electron which is coming out or ejecting or emitting from the metal surface, so that it has to move from the cathode to the anode. So how it is moving? By giving such an energy to that. So that if it is under motion means definitely you have to assume that here the electron which is going to be processed is the kinetic energy. So the mass of the electron is m and the velocity is v. So that kinetic energy formula is half m square. That's it. Next. So that here one electron, one photon which is going to be absorbing the, what do you say? One electron. So that photon is E equals to h nu. So it is to be ejecting from the metal surface, that means work function is the W naught, and also kinetic energy of mv square. This is the first equation. So this you can call it as photoelectric effect first equation. That means Einstein's photoelectric equation. This one. Please remember this. Next one. When the photon energy of the value, which can have only liberate the electron from metal surface, so that the kinetic energy of the electron will be 0. Therefore, if there is no kinetic energy, then definitely equation 1, W naught plus half mx square will be 0, so that it reduces h nu naught equals to W. When the case is going to be applicable in the initial state, so that the photon energy of value that can only liberate the electron from the metal surface. In that case, initial frequency that is called as threshold frequency. Not. So, which is called as minimum frequency, which can cause the photoelectric emission. Next. Other case is that you need to know that the threshold frequency for the long wavelength limit, which is going to be represent the upper limit of the wavelength for the photoelectric effect. The radiation have the wavelength longer than the lambda naught, would not be able to eject the electron from the given metal surface, where the which is having lambda is less than that of the lambda naught. So what do you say lambda naught? Long wavelength. So that is nothing but a upper limit of the wavelength. Next. So the equation for the lambda naught, which is given by pretty well in the initial classes, that means 8th, 9th, 10th, like that, where C equals to nu lambda. Okay. Or else you have to say that V equals to n lambda. For that case, if the initial frequency or initial wavelength, the lambda naught equals to C by nu naught. Or else here, what do you say? CH, that is speed of light into Max Planck equation, as well as the nu naught equals to W naught. This is the equation. According to the equation 2, W naught equals to H nu naught. By substituting all these values, you can have what is the lambda naught value. Next. So W naught in electron volts EV, by substituting all these, you are getting clear. Next, equation 3, which can gives the work function value. So 12,400 by lambda naught electron volt. Substituting in equation 1, that is W naught in place of W naught H nu naught. And similarly, this is the another form of the Einstein photoelectric. Equation 5, half m square equals to h into nu minus nu naught. Next, from equation 1, kinetic energy equals to h nu minus work function W naught. By substituting, you can have the values, so that nu square is proportional to nu here. Next. And also with respect to the threshold frequency, in previously we have been calculated the wavelength, and we are to be writing this equation in terms of the threshold frequency. Okay, reciprocal frequency and wavelength, which are reciprocal to each other, so that you can have the 7th equation like that. So how the stopping potential, which is going to be varying here. So what are the applications with respect to the photoelectric equation? So there is so many applications are there. So night vision devices. So there only we have to be using ultraviolet. So UV. So here photons, which is going to be entering, you just give the one such application, but they didn't ask you the applications according to BRAOU syllabus. And also photoelectric detectors are there, how to detect smoke by using these type. And also this one. This is the most important. That means nowadays in so many places. Now the solar panels which are going to be generating the electric current here. So these are the solar panels. That's it. About the photoelectric. One more is there. Yeah. Yeah. See here. So whatever we have been discussed, that is, in this, you can have the de Broglie wave. Okay. So de Broglie wave, which is associated with the moving particle. Moving particle means the particle which can have the momentum. Momentum means definitely you have to assume that the particle which can have the mass and as well as the velocity. P equals to mv. So which is associated with the moving particle means which can, where the wave travels the same velocity as that of the particle. Okay. Wave includes the particles, but the particle which can have the mass as well as the velocity. So that when the wave travels with the same velocity as that of the particle, the wave velocity, which is also known as phase velocity. So you can see here, W equals to nu lambda, not V. Nu is the frequency, lambda is the wavelength. And but according to the Max Planck equation, energy of the photon, light, nu equals to E by H, or E equals to H nu. And where E is the energy and H is the Planck's constant. But from the Einstein's mass energy relation, E equals to mc square. So where C is the speed of light, m is the mass of the particle. So in place of nu, E value, see here, this E is going to be substituted here. So that nu mc square by H, and also where W equals to nu lambda, in place of nu, mc square is substituted. Mc square by H is substituted, lambda is there. But lambda equals to, see here, but lambda equals, what is that lambda? H by mv, H by P. Okay, this is the de Broglie relation here. So by substituting in place of lambda, H by mv, so mm get cancelled. And also, what is the equation here? W value, which is nothing but a wave velocity value. You can have HH get cancelled. The remaining is HH cancel, cancel. That is C square by nu will get. So from this equation, here wave velocity and particle velocities are different. Getting my point? Particle velocity, this is the wave velocity, and the particle velocity which are different here. So that the particle velocity which is always less than the speed of light, C square, C is there. So the wave velocity W will be greater than that of the C. Why? Because of particles may include, wave may include the particles. Wave may include the particle. So that wave is generating, then only the energy, wave generating means here, you are giving such an energy to that. So that the particles which may absorb the energy, the particle can transfer from one particle to the another particle, this energy which can transfer from one to another. Okay, Nandi. Wave antene a combination of particles which can include the particles here. Wave generate avutundi ante enti, wave lo unnatuvanti particle which may transfer the energy from one particle to the another particle. Is it clear? Can you hear my voice? Hello? Mamata, Vani, Durga. Am I inpistunda voice? Can you hear? Hello?
Yes, sir.
Okay, right. So that like that here the wave energy, which is wave velocity, which is greater than that of the particle velocity. Okay. So this may be asked as a short question. Short question, only short question, not an essay. Please remember. Yeah, in textbook you may refer that here this is the photoelectric effect. ఇక్కడ డయాగ్రామ్ ఇచ్చినాడు సార్, మీరేమో పీపీటీలో ఏమో డిఫరెంట్ అయ్యారు. బోత్ ఆర్ సేమ్, యూ నీడ్ నాట్ టు వరీ, both are same. So we already explained this photoelectric effect. Later on, Einstein's explanation. Okay. So here they have been calculated the work function here. See here. Half m square equals to h nu minus work function W. This is called photoelectric equation. ఇది ఎట్లా వచ్చింది ఏందనేది మీకు ఇక్కడ అయితే ఇన్ డీటెయిల్ గా ఉండదు, నేను ఇచ్చిన పీపీటీలో అయితే యూ కెన్ సీ అండ్ అబ్జర్వ్ ది ఇన్ డీటెయిల్ ఈక్వేషన్. సో see here. What is that? Intensity of the light versus the frequency graph. Next, the most important, another most important question is that Compton effect. So many times, you can refer the previous question papers. So many times this question may be asked as a essay question, not short question. Short question, essay question, 10 marks question. So what it means, how the equation which is going to be deriving in this, let us discuss. So A.H. Compton in 1923, he has been discovered that a beam of X-rays, so X-rays which have been found by Röntgen. So X-rays which can have the wavelength is lambda theta, which is scattered. Scattering means where the waves can travel in all directions. So that how the scattering is going to be takes place, these waves which are going to be incidenting on a metal plate or a metal foil. So that definitely you have to assume that all the rays which is going to be scattered in all directions. So ikkada chudandi, idemo evacuated tube and idi. Okay, or else you have to say that X-ray tube. So X-rays which are going to be here generating and which is going to be hitting the metal foil that is made a graphite block. So that scattering is going to be takes place. చూడండి direction ఇది with an angle. చూడండి అన్ని directions లో మనకి waves ఉన్నాయి, ఇక్కడ waves arrow marks తో generate అవుతుంది. So this you can call it as a scattering in all directions. So what is the target of the X-ray tube here, which is a molybdenum. Okay, molybdenum. And also here the wavelength of this is 0.708 angstroms, and also monochromatic radiation which was employed in the scattering experiments here. Monochromatic means which can have only single wavelength. Okay, oka wavelength ganaka unte danni monochromatic anta. Mono means single. So that much of the light which is going to be incidenting upon this here, you can able to observe this. So what do you mean by T here? T is the radiation tube, radiation which is going to be entering. Radiation means X-rays, and P is the primary time, and S is the secondary line here. So that theta is the scattering angle, and B is the Bragg's spectrometer. Okay, so 2D sin theta equals to n lambda. That is also most important. సో అది కూడా డిస్కస్ చేద్దాం బ్రాగ్స్ లా గురించి. సో ఇక్కడ బ్రాగ్స్ స్పెక్ట్రోమీటర్ ద్వారా మనకి ఎంత షిఫ్ట్ అనేటువంటిది ఏర్పడుతుంది అనేటువంటి యూ కెన్ ఈజీలీ ఇమాజిన్ దట్. సో దిస్ ఈజ్ అబౌట్ ది ఇనిషియల్ స్టేజ్ లో మనకి when theta equals to 0 degrees, by changing the scattering angle, how the shift is going to be takes place with the incident to the here scattered wavelength. So that the wavelength lambda naught and lambda theta. Lambda theta is scattered angle here. So lambda naught, which is a initial. By changing you can able to see the shift here. When theta equals to 0, both are to be closer to each other. Theta 45 degrees. A small dip is there. Theta 90 degrees. Variation is going to be takes place. By increasing theta equals to 135 degrees, yes, definitely there should be a separated two wavelengths are going to be takes place. So here, yeah, you can see here. So this is the diagram, first A figure A and figure B here. So by the theory of the classical mechanics here, the electromagnetic wave which can have the wave frequency nu naught, and which is going to be interacting with the electrons in matter, and also oscillating the electric field, which is going to be driving the electrons in forced vibrations with the same frequency. and these electrons then irradiate the absorbed energy in the form of electromagnetic waves and in all directions with such a frequency mu naught. And here the classical theory cannot account for observe the modified line in the quantum. Okay, so the existence of the modified line capital M in the scattered radiation, which was accounted by the Compton, making use the quantum theory, not by the classical theory. So incident radiation H nu naught, here H nu theta and other direction. Okay, radiated of m square along with that, which is going to be deviating here. So you can have the conservation of energy of the collisions. So there should be a collision is going to be takes place, hitting the here molybdenum metal foil, the radiation. So that definitely collision is going to be takes place. So the energy is of m square, and also the electron recoils by the incident X-ray quantum. That the incident means H nu naught initial. So the X-rays which can move off to some new direction as that of the lower frequency H nu theta by the conservation of the energy here H nu naught equals to H nu theta plus the electron which is moving with the kinetic energy of m square. And also here where the velocity of the electron is v here. So according to that of m square equals to, according to the Einstein's equation, E equals to mc square. That is mc square, not by the 2 square is there, print mistake, and m naught c square, rest mass of the electron, m naught. So what is the relation between the m to the m naught here? M naught by gamma, special theory of relativity lo untundandi. So m ki m naught ki relation entante m equals to m naught by gamma anochu. Now gamma means square root of 1 minus v square by v square. So this is the condition. So by substituting and simplifying this equation, you can have the k values. We need to do the practice. Okay. Again, you can substitute in the first equation, that is this in this equation. So you calculated the of m square value and the h nu naught value. There only by substituting, you can have the momentum. That means p value, that is h nu by c, and how it is going to be deviating here before collision and after collision here. So you need to do, you have to calculate that here. What is the Compton shift value? Compton shift. This is the this is the equation, final equation. So Compton shift value, lambda theta minus lambda naught equals to shift delta. I already show you the Compton shift value from the initial to the here scattered angle. So that when the angle is going to be increases, how the shift, what is the shift value is to be takes place here. So that the Compton which has been modified that equation and derivation 3.17 h by m naught c. H is the Planck's constant, m naught is the rest mass of the electron, c is the speed of the light, and along with the 1 minus positive. So up to here you need to do the practice. You need to do the practice. Without doing the practice, you cannot able to remember the calculation. Next, dual nature of the light. What do you mean by dual nature? This is also asked as a short question. Short. But according to the Newton corpuscular theory, the light which can travels by the only by the particle. Okay, but this theory, corpuscular theory, which was failed to explain most of the properties of the physics here, and later on, Eigen, he has entered into the picture. He is going to be proposed that not by the corpuscular particles, the light energy which can travels like a waves here, but wave can include the particle. So that whatever the failures which have been taken and chosen by the Newton's corpuscular theory, So Huygens wave theory successfully explained. Okay. So there should be interference, diffraction, polarization, refraction, reflection. All these comes into the picture here. But you need to explain with respect to the figures. Figure, at least. Next, what is the concept of the matter waves? This is also short. Matter waves. If there is a matter, you need to understand that definitely it consists of a mass. Okay. So see here. When the radiation sometimes displays the characteristics of particles. That is, particle means definitely there is a mass. Matter means mass. So why not matter like wise sometimes display the characteristics of waves. So here, according to the de Broglie's, the matter waves. So you can have the energy of the photon is equals to h nu. And according to the relativistic theory, special theory of relativity, that is nothing but a relativistic theory, which was proposed by the Einstein in 1905. Einstein. So what is the relation between the energy to the rest mass and momentum? So this is the case. Please remember this. E by c square, E by c whole square equals to p square plus m naught square c square, where the photon has no rest mass. Photon rest mass undadandi. So for that case, m naught value is 0. By substituting, E by c whole square equals to p square, or else E by c equals to p. What is E? E is the energy, c is the speed of light, p is the momentum. But E value h nu, photon energy equals to h nu. H nu by c equals to p. Or nu by c ante entandi? Nu by c, lambda. తెలుసా లేదా? Nu equals to c lambda. Okay. Sorry, nu equals to c by lambda. ఎట్లా? V equals to మనము ఏమన్నాం చిన్నప్పుడు చదువున్నాం. V equals to n lambda. V is the velocity, n is the frequency. C equals to nu lambda. So nu is the frequency. N బదులు nu రాసినాం, lambda, V బదులు c రాసినాం. So c by lambda is nu. So you can see what is E? E equals to h nu. New place లో ఏం రాసుకోవచ్చండి? New place లో c by lambda. That means c get cancelled. What do you have? H by lambda equals to p. Or since c equals to nu lambda, ఇక్కడ ఇచ్చినాడు కింద. ఇవన్నీ ఎప్పుడు పాసిబుల్ అంటే you need to do the practice. So lambda equals to h by p. P ante momentum. Momentum equation is mv, mass into velocity. And you know pretty well kinetic energy of m square. Maybe this question చూడండి. You can do the what do you have? Velocity if you want to calculate it, or momentum, or else if you want to calculate the lambda value, you need to remember this equation of m square, or else v equals to 2e by m or 2k by m. దీని ఎనర్జీ E అనుకోవచ్చు, లేకపోతే కైనెటిక్ ఎనర్జీ అంటున్నాడు కాబట్టి k అండి, 2k by m. సో కైనెటిక్ ఎనర్జీ ఇచ్చినాడు. And here this is the charge of the electron and this is the mass of the electron. 9.1 into 10 power minus 31. Mass of the electron 1.6 into 10 power minus 19 coulombs. Charge of the electron. So by substituting, you will get the wavelength. Next, experiment of Davison and Germer. This is also essay question, not short. Okay, Nandi? So this is the third question we are discussing. First is the photoelectric effect. Next one is the which one, Andy? Compton effect. Third one is the Davison and Germer. So here X-rays and de Broglie's matter waves, which was suggested by the method of experimenting on the diffraction of X-rays. Diffraction of X-rays would not be extended to matter waves. Okay, matter waves are different. So in 1927, DJ Davison and L.H. Germer, those have been performed an experiment using a beam of electron instead of X-rays. Adi, what is the different enti ante manaki ikkada in place of X-rays ku badalu electron rays ni manaki ikkada vaadakam jarigindi. Electrons ni vaadakam jarigindi in this experiment. So ikkada manam chusinattlaithe this one here. So this is the high voltage battery rheostat voltage and a beam. See here, incident beam is there, IV, and F is the filament. See here, ikkada undi filament, and RB is the reflected beam, and C is a crystal. This is the crystal here. D is the detector, and P is a plate. This is the plate. So this is the experimental setup here. You just want to look at the what it consists of here. A tungsten filament. How the filament is going to be heated? By this circuit only. By this circuit. And the battery is there, high potential difference is there. So that according to the through the resistance, so that the filament which is going to be heated here. Okay. So when the filament is going to be heated means which is going to be emitting such a energy. That means which is going to be emitting the electrons with a kinetic energy Ke. So by applying such a potential difference to that, and which is going to be passing through a fine parallel pencil here, a beam like that. So దీని నుంచి మనకి ఇక్కడ electrons అనేటువంటివి బయటికి వస్తూ ఉంటాయి ఇక్కడ నుంచి. So which is going to be incidenting upon a plate here. So what you have, which is going to be reflection is going to be takes place. Okay, ఈ డైరెక్షన్ లో రిఫ్లెక్ట్ అవుతుంది. ఈ రిఫ్లెక్ట్ అయినటువంటి రేస్ ని మనము ఇక్కడ డిటెక్టర్ ద్వారా which is going to be detecting and identifying that. That is the case. అదే చెప్తున్నాడు ఇక్కడ చూడండి. A beam travels in a free space, falls normally on the single crystal nickel at C. What do you mean by C? C is a nickel crystal. So here the entire process which is to be enclosed in a vacuum chamber. So the reflected electrons which may be మరి ఎలక్ట్రాన్ ఎట్లా మనం చూడగలుగుతాం అంటే డిటెక్టర్ ద్వారా which is going to be connected to the detector, and so that the detector which is going to be showing the spark, a light spark. So detector D, that is consists of a Faraday's chamber, and again the cylinder which is surrounded by another cylinder which is separated the applied retard potential. Next, the cylinder, only those electrons whose velocity after reflection of the same order as the velocity before the reflection. Before entaithe velocity undo, after the reflection is also the velocity of the electron which is same. So that which is going to be prevents the electron of the lower energy from the detector. And if you want to set the angle here phi to the incident beam here, see this is the phi. This is the phi. So that the reading of the intensity of the reflected beam which is going to be noted with the by changing the potential change అవుతూ ఉంటే ఇక్కడ మనకి యాంగిల్ ఎట్లా మారుతూ ఉంది అనేటువంటిది మనకు కూడా మనం ఐడెంటిఫై చేయొచ్చు. See here, most intense at 50 degrees for 54 volts. చూడండి, from graph only with respect to the current, with respect to the voltage. See here, 50 degrees, most intensive side. Like that you need to, by where this equation comes out from the Bragg's law, 2d sin theta equals to n lambda. D value you have to substitute, and you need to calculate the what is the lambda value. The principle of complementary, is not to be asked. Yeah, concepts of different velocities in matter. Yeah, see here, Most important short question. Relation between different velocities. The relation between the group velocity and particle velocity. చాలా సార్లు అడిగినాడు ఈ క్వశ్చన్. చూడండి, రిలేషన్షిప్ బిట్వీన్ గ్రూప్ వెలాసిటీకి పార్టికల్ వెలాసిటీకి ఏంది అసలు డిఫరెన్స్ ఏంటండి? సో లెట్ us consider that VGW. What do you say? VGW with the velocities of moving particle, group of waves, and a wave comparison the group respectively, so that the lambda be the wavelength and the group velocity of the system contains number of waves. Group ఉందంటే ఖచ్చితంగా అక్కడ ఏమున్నట్టు నెంబర్ ఆఫ్ వేవ్స్ ఉన్నట్టు, వేవ్ ఉందంటే ఖచ్చితంగా ఏమున్నట్టు అక్కడ పార్టికల్ ఉన్నట్టు. కాబట్టి ఒకదాంతో ఒకటి అక్కడ లింక్అప్ అయి ఉన్నది. చూడండి, సో దట్ G ఈక్వల్స్ టు W మైనస్ లాంబ్డా. దీన్ని మనం DW బై D లాంబ్డా మనకి ఎందులో ఉంటుందంటే మనకి క్వాంటమ్ థియరీ ఆఫ్ క్వాంటమ్ మెకానిక్స్ లో ఉంటుంది, షోడింగర్ వేవ్స్ లో ఉంటుంది. అక్కడ మనకి డెరైవ్ చేస్తాం ఈ ఈక్వేషన్ డైరెక్ట్ తీసుకున్నాం. సో ఇన్ ఫ్రీ స్పేస్ అంటే అక్కడ ఏ విధమైనటువంటి మీడియం లేదు కాబట్టి d ఒమేగా బై dw ఈక్వల్స్ టు లాంబ్డా ఆర్ఎల్స్ G ఈక్వల్స్ టు W. సో ఇక్కడ 0 అయిందంటే అక్కడ ఏమవుతుందండి, G ఈక్వల్స్ టు W. సో ఫర్ ఏ డిస్పెన్సివ్ మీడియం ఉన్నది అనుకోండి, మనకి ఇక్కడ ఏంటి, G ఇది గ్రూప్ వెలాసిటీ, W is the wave velocity. Group velocity which is less than that of the wave velocity. So that for this case dW d lambda is positive. Next, you need to mention the conditions here. So G equals to here lambda square into W by lambda square minus 1 by lambda into dW by d lambda. What do you say? Multiplying and dividing right hand side of the equation 3 in the above equation with the lambda square. So that by doing and by simplifying this, you can have the relation. You will get it here like this. G equals to minus lambda square into lambda by d lambda by dV by d lambda. So this is the equation. And how to calculate the total energy? Total energy means sum of the potential and kinetic energy. Okay. U plus V equals to E. U is the potential energy, potential energy, V is the kinetic energy, and capital E is the total energy. E minus V equals to kinetic energy. So that V equals to 2 by M into E minus V whole power R. By doing this is about the substituting de Broglie's wave relation. You can have this. And comparing with the wave velocity. So we will get this. G equals to. You need to do this. Sometimes this may be asked as a short question, as well as by combination of the two short questions, they may be asked as a short question. రెండు షార్ట్లు కలిపి ఒక ఎస్సే ఇవ్వడానికి ఉంది, లేకపోతే సింగిల్ గా ఒకే ఒక షార్ట్ అడగడానికి ఛాన్సెస్ ఉంది. So in this case, G equals to V, so that the group velocity of the de Broglie wave which is associated with the, what is V? V is the velocity of the particle. That is the case. Next, relation between group velocity and phase velocity. అక్కడేమో మనము రిలేషన్ బిట్వీన్ గ్రూప్ వెలాసిటీ అండ్ పార్టికల్ వెలాసిటీ, ఇక్కడ వచ్చినప్పటికి గ్రూప్ వెలాసిటీ అండ్ ఫేజ్ వెలాసిటీ. గ్రూప్ వెలాసిటీ మనకి వేవ్ వెలాసిటీకి సంబంధించి W equals to V lambda, de Broglie's equation H by mg. So here H by mv అనొచ్చు, లేకపోతే G అనొచ్చు. V is the velocity, G is the acceleration due to gravity. So according to that, ఇక్కడ nu equals to వస్తుంది. ఇక్కడ ప్రింట్ మిస్టేక్ ఉంది, nu into E by H కాదు, nu equals to E by H. You can see so many mistakes are there. How to identify all these means by doing the practice. So see here, W equals to half G or G by 2. That means the wave velocity or the phase velocity is half the group velocity. W is the wave velocity of the group velocity. Wave velocity ఎప్పుడు కూడా గ్రూప్ వెలాసిటీకి సగం ఉంటుంది, G by 2. Next, uncertainty principle. This may be asked as a short, but not an essay. Consequences according to the Paulus. Uncertainty, where it is to be takes place here with respect to the energy as well as the here time. There should be uncertainty and the position with the momentum. Okay, and also position with the here momentum should be right m into v. So how it is changing here. So this is also a short. Yeah. See here, what are the questions? What is photoelectric effect? There is the Einstein photoelectric effect. What is Compton effect? There is the expression for it. Next. Photoelectric effect, Compton, and also Davison and Germer. That is also there. Short questions you can see here. Wave velocity is half the group velocity. Uncertain. There are the worked examples for that. Yeah. Schrodinger wave equation. Most important one. Time dependent and time independent. రెండట్ల నుంచి పక్క 100% of question ఉంటుంది. Okay. Time independent wave equation or time dependent wave equation. Next, Born interpretation. Short question. Eigenvalues and eigenfunction. That is also short. Schrodinger time independent wave equation. చూద్దాం ఇక్కడ ఒకసారి. Consider a moving particle moving freely along the x direction, positive x direction. Particle అన్నాడంటే ఖచ్చితంగా మీరు ఏమైనా అజ్యూమ్ చేసుకోవాలి. పార్టికల్ ఖచ్చితంగా మూమెంటం ఉందని. మూమెంటం ఉందంటే మాస్ యాజ్ వెల్ యాజ్ ది వెలాసిటీ m into v. నెక్స్ట్ కైనెటిక్ ఎనర్జీ మీన్స్ హాఫ్ m స్క్వేర్ ఉంది. అండర్ మోషన్ లో ఉందంటే కైనెటిక్ ఎనర్జీ. సో దీన్ని మనం ఎట్లా రాయొచ్చండి? p²/2m. ఎందు గురించి p ప్లేస్ లో mv సబ్స్టిట్యూట్ చేయండి. m² v²/2m చేసినాం అనుకోండి. ఓన్లీ దట్ ఈస్ పాసిబుల్. ఏదో బై హార్ట్ చేసి బండ గుర్తుగా చదువుదాం అంటే మీకు రాదు. అది అన్ని మిస్టేక్సే. మేము పేపర్ కరెక్షన్ చేస్తున్న అన్ని మిస్టేక్సే ఉన్నాయి. మక్కి అందరు చూసి కాపీలే. p మీన్స్ mv, m² v². p మీన్స్ mv, mv ని హోల్ స్క్వేర్ చేయండి. m² v²/2m. m వన్ టైం క్యాన్సిల్ అవుతుంది. ఎంత అండి ఇక్కడ? అడిగిసే mv², half mv². So that this is the kinetic energy. Like that. At least you need to do the practice. So here energy momentum మనకి రిలేషన్ ఏంటంటే p = h/λ. అంతకుముందే మనం చేసినాం. మనం దాన్నే E = h తెలుసు మనకి. ఓకే, let us consider that the waves which are associated with the particles. అవునా కదా? వేవ్ ఉందంటేనే ఖచ్చితంగా అక్కడ పార్టికల్స్ ఉన్నట్టు. సో లెట్స్ ఇస్ ఫ్రీక్వెన్సీ nu and the wavelength is lambda, which are traveling, so that which you can represent the wave function is psi. What do you say? Psi. కాబట్టి such that psi1 = a1 cos 2 pi into x/λ minus vt. Okay, vt. And also reflected wave traveling in opposite direction. One direction లో వేవ్ పోతుంటే అదర్ డైరెక్షన్ లో రిఫ్లెక్ట్ అవుతుంది. సో psi2 = a1 cos 2 pi x/λ minus μt. So by adding these two, you can have the resultant wave psi1 plus psi2, 2a1, 2a cos 2 pi lambda into cos 2 pi Newton. So this is the product of two terms. Product will gives you like this. So the time independent term function of t is a cos 2 pi Newton. And with respect to the position and time, the wave function which is denoted by position and time. So by differentiating this equation, d square psi by dx square with respect to position, you will get like this. After getting this, if you want to calculate the energy, d square by 2m plus potential energy, or else by simplifying and by substituting, you can have this equation. So this is called time independent wave. What about the time dependent wave equation? So time dependent is equals to a exponential 2 pi I x by lambda minus u. One thing I suggest you that here, if you want to get the clear and simplest form of the derivation, which is related to the Schrodinger's time as time dependent as well as the time independent, better to go for the regular UG physics book, Unified Physics. Unified Physics ఒక్కసారి చూడండి. సో దట్ అది ఇంకా చాలా సింపుల్ గా ఉంటుంది డెరివేషన్ పార్ట్. అది రాసినా కూడా వీళ్ళకి ఏదో మార్క్స్. ఓకే, సో దిస్ యూ కెన్ హ్యావ్ ఏ కాంప్లికేటెడ్ బై హార్డ్ చేయాలంటే, బై హార్డ్ చేసేది గుర్తుపెట్టుకోవాలంటే విచ్ ఈస్ వెరీ డిఫికల్ట్. సో వాట్ ఐఎమ్ సేయింగ్ ఈజ్ better to go for the unified physics, for the modern physics. There you can have time dependent as well as the time independent derivation లో ఉంటుంది. అందులోనే మనకి ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్ ఉంటుంది, కాంప్టన్ ఎఫెక్ట్ ఉంటుంది. ఓకేనండి, డేవిసన్ అండ్ గెర్మర్ ఎక్స్పెరిమెంట్స్ ఉంటాయి, న్యూక్లియర్ ఫిజిక్స్ ఉంటుంది, అన్నీ ఉంటాయి అందులో. గో ఫర్ దే. సో బై దట్ ఫంక్షన్ మనం వేవ్ ఫంక్షన్ ఎట్లా ఫైండ్ అవుట్ చేయొచ్చు, ఎనర్జీని ఎట్లా p square by 2m plus 5 if you apply and multiplying with the wave function. So energy E psi equals to h cross by into dou psi by dou t. And also here you have to calculate the, what is this E psi equals to, here what do you say, this is p square by 2m plus v. That value should be minus I h cross dou psi by dou t equals to minus h cross square by 2m dou square by dou x square plus v psi. Here with respect to time, here with respect to the position. That means wave function with respect to position and time, if you are to be considering here how the time dependent as well as the time independent equations are to be derived, so you can easily go through this. Next, eigenvalues and eigen functions here. So the value of energy of the Schrodinger's, he has been solved the equations which are known as the eigenvalues, which are corresponding to the wave functions which are known as eigenfunctions. No need of milligram. So see here, time dependent, and this is the time independent. In time independent, you can have I h cross. Here time is there. This equation is wrong. That is not plus, equals to. Better to check it once. Print mistake chala undi. Idi chuddam. So by coming class we will discuss about the here applications of Schrodinger wave. Particle in one box. What is the potential difference? Potential barrier. One box లో ఉన్నప్పుడు పార్టికల్ దాని యొక్క ఎనర్జీని ఎట్లాగా, దాని యొక్క వేవ్ ఫంక్షన్ ఎట్లా మనం జనరేట్ చేయొచ్చు, ఎట్లా చూపించచ్చు అనేటువంటిది మోస్ట్ ఇంపార్టెంట్. పొటెన్షియల్ బ్యారియర్ గురించి. సో ఒక్క టాపిక్ మీకు ఒక 10 minutes లో చెప్తాను. లేటర్ ఆన్ వీ విల్ డిస్కస్ ఉంటుంది బ్లాక్ 3. నెక్స్ట్ మే, నెక్స్ట్ వీక్, ఈ వీక్ లోను మనం మే ఫస్ట్ వీక్ లో ఉన్నాయి కాబట్టి Friday, Saturday, Sunday, there we can discuss the block 3 as well as the block 4. Okay, so today I'm going to be concluding this. If you have any queries related to this, you can ask me directly. Any questions? My suggestion is that better to purchase a new book, Unified Physics. Write it down. Unified Physics. చాలా సింపుల్ గా ఉంటుంది, చదవడానికి చాలా ఈజీ ఉంటుంది. రెగ్యులర్ డిగ్రీ పిల్లలు కూడా అందరు అదే చదువుతారు. సో ఇక్కడ మనకు ఒకదానికొకటి లింక్ లేదా డైరెక్ట్ ఈక్వేషన్స్ మనం ఇన్ని రిమెంబర్ చేసుకోవాలంటే ఇట్ ఈస్ డిఫికల్ట్.
Sir, it is unified physics or united physics, sir?
Unified.
Okay.
Unified Physics. ఓకే. సో మీరు అక్కడ ప్రాక్టీస్ చేస్తే మీకు ఈజీ, చాలా డెడ్ ఈజీ ఉంటుంది. అంత డెరివేషన్ పార్ట్ అంతా కూడా మీకు చాలా ఈజీ ఉంటుంది. ఫార్మల్ లాంగ్వేజ్ మీరు అది రాసినా కూడా వీ విల్ గివ్ ది మార్క్స్. నో నీడ్ టు వరీ అబౌట్ దట్. వీ నీడ్ ది కాన్సెప్ట్ అండ్ వీ నీడ్ ది ఈక్వేషన్స్. డెరివేషన్ ఎట్లా చేసినారు, ప్రాపర్ చేసినారా లేదా అది. ఓకేనండి? రైట్, ఆల్ ది బెస్ట్.
Thank you, sir.